Okay, so the last couple of assignments that we've done have been about inequalities and understanding inequalities and what their answers actually tell us. We want to work with them just like we would an equation with that one little trick when we multiply or divide by a negative number. We don't want to forget that, but what I have up here now is two-step inequalities, and we treat them just like we would if it was a two-step equation. We just have to remember that trick. So I have two of them up here I'm going to show you guys, and then I think you'll be able to do all 10 that are on today's problem or today's assignment. So remember, this is our equation sign. That's our inequality. It would be like where our equal sign goes. And we want to do the same thing as if it was an equal sign. We would say, okay, here's my variable that I have to get alone. It's currently timesing by 5, and then we are subtracting 3 from it. So remember, you always want to work furthest away from your variable on that side and then slowly get rid of things with it, okay? So we want to get rid of this. We even call it our stranger. Remember, this is you and your best friend, and we have our stranger with it. So we would do the opposite to get rid of it from that side, and to keep it equal, or the idea of equal, we have to do the same thing on this side. So negative 3 plus 3 is gone. We still have 5x over here, and it is less than or equal to negative 23 plus 3. Well, negative 23 plus 3 is a negative 20. I have 20 more negatives. I add 3 to it. I can even think of it like I owe somebody $23. If I pay them $3, I still owe them $20. So that's another way you can think about it. And now we have one more step to get our variable alone. So we have to get rid of this 5, and we are timesing by 5. So now we want to divide by 5. We want to do that opposite to get my variable alone. That is going to be my inequality, less than or equal to. Over here I will divide by a 5. Now, what I wanted to show you with this one is we have a negative 20 divided by 5. Our trick was if we multiply or divide by a negative number, not if we multiply or divide a negative number. So it doesn't matter what this is, it has to be multiplying or dividing by a negative number. You see that? So because this 5 wasn't negative, we don't flip that sign. Totally okay for our number over here to be negative. It just tells us that our answer will be negative 4. So I want you guys to realize that you have to be multiplying or dividing by the negative, okay, in order to switch that sign. It'll happen over here. Let me show you. This is our inequality sign. It would be like where our equal sign would go on an equation. And we want to do the same thing. This is you and your best friend. We need to get rid of the stranger in the car. So to get rid of a positive 8, we would subtract 8. So subtract 8 from both sides. 14 minus 8 will give you 6. It is greater than a negative 2y. So now negative 2 is multiplying by y. So we divide by a negative 2. You can hear it when I tell you the steps. Divide by a negative. So over here we will divide by a negative 2. Now, because I divided by that negative, I know that sign is being flipped. That was my trick from Friday or whatever. So 6 divided by a negative 2 is a negative 3. I've already flipped that sign because I divided by a negative. And then over here we have a negative divided by a negative, which is a 1 and y. So I want to make it perfectly clear when you are flipping the sign, dividing by a negative, and when you're not flipping the sign, if you're not dividing by a negative. Now, if I wanted to graph these on a number line, it would show me what it actually means. So I would say, okay, I have negative 4 with its two numbers around it. I know that it is equal to. If it's equal to, that means I include it. So negative 4 works in order to make this equation true, or this inequality true. Now, because my variable is already on the left-hand side, I can do my arrow trick. If you don't understand that, then you can plug a number in. You can say, okay, is -5 less than or equal to -4? Yes, it is. I know I am going the way that -5 goes. Now over here, you'll notice that your variable is not on the left-hand side. I can flip it, and I would have to flip everything. So -3 is less than y, or y is greater than -3. It's saying the same thing, just in a different way. And on our number line, we would want -3, -2, -4. In this case, we're not including -3 because there's not an equal to sign underneath it. So we keep that open circle. And now we can say, okay, well, is -4 greater than -3? And it's not. So we won't go this way. We'll actually do our arrow trick, and it will make us go the way of -2. So what it's saying is, if I plug in any number that is greater than -3 into this original equation, it is going to give me a true statement. So what I'll show you is something like this. 14 is greater than -2. Now a number greater up here, a number bigger up here would be like 2. So I'm gonna plug it in. Plus 8. -2 times 2 is a -4, plus 8 is 4, and 14 is greater than 4. Makes it true. If I was to plug in something from this side of that number line, it would make it not true. And same thing would happen over here. Plug in something on this side, it would make it true. Plug in something on this side, it would make it not true. So that's a way to tell. Hopefully you understand really what we're trying to find with inequalities. Good luck on your guys' assignment.